Hello, this is section 4.3 OSPF. Okay, before I complete this section, let's review what OSPF is. So this is OSPF cheat sheet. I have created this image to explain OSPF concept. Okay, OSPF is linked state routing protocol. It uses the register algorithm. It uses two kind of multicast addresses. One is 224.0.0.5 for all OSPF routers and 224.0.0.6 for DR and BDR. It uses the administrative address of 110. It supports BLSM and it uses parent and MD5 authentication. It uses protocol number 89 and cost as metric. This is OSPF cost formula. This is OSPF packet types. We have hello. Hello discovers and maintains neighbors. We have database description, DD. This is for summary of database. Then we have link state request, LSR. This is database download. Link state update, LSU, database upload, and link state acknowledge. Link state ACK, LSACK, LSACK, or LSACK. LSACK is for flooding acknowledgement. Okay, OSPF adjacency status. We have down state. We have attempt. It is used only in MBMA, non-broadcast multi-access. We have init state. Init state hello has been seen. We have proven. In two-way state, OSPF routers can see their own IDs. Is two-way state. We have extract. It establishes MS relation. We have exchange. It is sent in action state. It sends DD. This is database description. This is summary of database. And we have loading. Loading state. It sends link state request. And this is link state LSR. And in full state, we have full addresses. Okay, we have three important concepts. One is router type, network type, and link state LSA type. This is summary of all three. Okay, let's first understand OSPF router types. I will explain this image. So we have R1, R2, ABI, R3 ABI, and R4 here. This is area 2, 0, and area 51. Okay, first we have internal router. This is IR. All interfaces are in the same area. This is here are 4, R1 are internal routers. If I draw one, but there are one router here, it is internal router. All interfaces are in the same area. Then we have backbone router. We have backbone router, and it has at least one interface in area 0. Okay, here are two RT and this, well, let me offer. This, they are backbone, what it is. So they have at least one interface in area 0. Then we have ABR. ABR connects to area to one to connect two area together. This is two more area to this ABR. Then we have ASPR. Okay, ASPR. Let me explain what is ASPR. Here, if we, I will explain this LSA type later. Let me explain it. Here, if we redistribute this prefix into this is first we have read routing protocol here. Then if we redistribute this prefix into OSPF, then this R1 will become ASBR. This is ASBR. We have redistributed flip into OSPF, and now become ASPF. Okay, let's now explain LSA type. Now we understand what are ABR, ASBR, and internal order. Okay, let's say 1. This is type 1.ASA. Type 1.ASA stays within the area. You can find directly connected links of our order in LSA number 1. And if in show attribute command, we will see all entities for LSA number 1. This is type 1, list routers, interface and cost, and flooded within the area. This is only stays within the area. We have type only stays within the area type 1. Just directly connected links. We'll show directly connected links in type LSA type 1. Okay, we have LSA type 2. It is the same as LSA type 1, it starts within the area. LSA type 2 only being generated by DIA, which is important to understand. I will explain that for types later. We will see what is LSA type 2. Okay, LSA type 2 only generated by DIA. We will see all entities in show attribute. Then we have LSAT. This is type T summary LSA. LSA type T flows into all other areas of our OSPF network. LSA type T is being generated by ABR. Let's see this here. LSA type T is being generated by ABR or ABR. ABR only generates LSA type T, and it's flooded to other areas. Originated by ABR and advertised among areas. This is type T. Then we have LSA type 4 and type 5. Okay, LSA type 4 and type 5 are close to each other. LSA type 4 is type 4 summary ASPR. Is type 4 summary ASPR LSA, and type 5 is type 5 autonomous system external LSA. Okay, let's see here. Okay, if we redistribute this strip into OSPF, then R1 will become ASPR, then R2, that is ABR, will inform other routers in other areas where ASPR or where R1 is, which is the job of LSA type 4, to, to inform or advertise our ASPR to other areas in OSPF. In other words, LSA type 4 is only generated by ABR, not ASPR. R2 will generate type 4. So the RT. Type 4 is flooded to our areas of OSPF network and is being generated by ABR, not ASPR. But LSA type 5, this is the same as LSA type 4, is flooded to other areas, but it is being generated by ASPR. Let's see here. If this flip, then R1 will become ASPR, then R1 will generate LSA type 5. Okay, LSA type 4 is originated by ABRs and is to advertise the presence of our ASPR within the area. This will advertise this. This will advertise the presence of our ABR. This is R1. R2 will advertise this presence of our R1. Will inform other routers that where our ASPR is. Okay. And type 5, this is originated by ASPR and followed by the routers. So this is a type 4 and type 5. In other words, without LSA type 5, we don't have LSA type 4. Okay, now we have LSA type 7. This is not so stable area LSA. Okay, now if we make this area 2 as NSSA, it's not so stable area. And because this is NSSA area, then type 5 LSA are not allowed. This is, we can't have LSA number 5 in NSSA area. NSSA area will not allow type 5 LSA. Instead, it will generate type 7 LSA. And because we have LSA area, it's flat into only LSA area and is being generated by ASPR within NSSA area. If I see this picture here, it's only being generated by ASPR inside NSSA area. In other words, R1 will generate type 7 LSA. R1 will generate type 7 within the LSA area and and is being generated by next ABR order from 7 to 5. Then this R2, that is ABR, will translate this 7 to 5. Another word is being generated by other ABR. ABR will translate this 7 to 5 and flow to other areas. Okay, in LSA, for LSA type 5, we will see OE1 or OE2 entities in short root, and for LSA type 7, we will see ON1 or ON2 entities in short root. So this was the OSPF LSA types, and we have one more important concept of OSPF network. Now we will understand this OSPF network better. We know what are our OSPF data types, OSPF network types, OSPF link state types. Now we will see what are OSPF network types. But this is quick summary for LSA network, LSA types. This is backbone. This is backbone area. For backbone, we have LSA type 1 and 2, 3, 4, 5. We don't have LSA type 7 in backbone area. Same as no backbone areas. If I see this picture, backbone is at least one interface in area 0. No backbone, no backbone, start, and we have a stop. In this stop, we have, let's say, 1, 2, 3, 4, and we don't have 5 and 7. Stop, we don't have 5. In total stop, we have, let's say, 1 and 2. We don't have, let's say, number 3 and 4. We don't have 5 and 7. And in not so stop area, we don't have, let's say, type 5. Type 5 is not already not stop area. But we have, let's say, 1 and 2, 3 and 4 and 7. Okay, now let's OSPF. Let's review OSPF. It's important for our scenario to understand what we have to do. Okay, OSPF network types. We have point-to-point, point-to-multipoint, point-to-multipoint not broadcast, MBMA, broadcast, and non-broadcast multi-access. Okay, OSPF network point-to-point. In point-to-point, this implies the single circuit between two directly connected routers. OSPF hellos are sent in all OSPF routers. This is multicast address are 5 to 4005. In point-to-point, we have automatic neighbor discovery. Then no SPF network command is needed. This is point-to-point. We don't have to specify network command. We don't have the election. This is point-to-point. And this is hello and time intervals. Okay, point to multipoint. This is another point to multipoint. We have two contact point to multipoint. One is point to multipoint, so broadcast, and point to multipoint non-broadcast multi-access to MBMA. In point to point network, this is a collective of point to point links. OSPF failures are sent in multicast address of this file. Automatic neighbor discovery, we have automatic neighbor discovery, so OSPF network command is needed. If no OSPF network command needed, we don't have to specify network. Because this is OSPF and no BDR election, this is important. In point to point, it advertises hash route, which is it advertises /32 for all the firmware endpoint. This one it advertises the route as /32 point to point. And this is our timers. Then we have broadcast. This default for Ethernet interface. OSPF allows us send in out of the multicast address. We have automatic neighbor discovery. Then no OSPF network is needed. And it requires BDR election in broadcast. BDR election is mandatory. And this is all on time. Then we have non-broadcast multi-access MBMA. This is default for OSPF enable frame relay physical interfaces. In the MBMA, OSPF hellos are sent in unicast to each node. We have unicast. Because we have unicast, then no automatic neighbor discovery. We don't have automatic neighbor discovery. And the OSPF network command is mandatory here. We have to use neighbor command. And it requires DR and BDR election. And this is our around the type. Okay, let's in summary, networks that have point. First of them is, for example, point to point, point to multi-point, or point to multi-point multi-access. In all of these networks, we don't have DRBDR election. Then we don't have type 2 LSA. Type 2 LSA is only for DR. DRBDR election also for MBMA and broadcast. Only in broadcast and on-board MBMA we have DRBDR election. Network that have point, we don't have DRBDR election. In non-broadcast networks, such as point-to-point, point-to-point non-broadcast multi-access, and non-broadcast multi-access (NBMA), hellos are sent via unicast. Hellos are sent via unicast. Then our neighbor command is needed. We have to use neighbor command in non-broadcast networks because hellos are sent via unicast, not multicast others. In broadcast networks, hellos are sent via multicast. So this was the summary of our OSPF network. Let's jump to conversion. We know that type 2 we don't have any type 2 for point network, point-to-point networks. Okay, now let's confirm. Before I confirm, let's review one. This is OSPF authentication and for OSPF configuration. This is okay. We can configure OSPF in two ways. In other words, we can advertise network in OSPF. This is advertise network. We can advertise in interface level by IP OSPF number, area, and number. It is a process number. The IP OSPF on the interface level. On interface level, we can use IP OSPF process ID number and then type area and number. If I configure this on the interface, it will advertise on network. Or you can configure to OSPF process ID, then type network, our favorite network, and area number. It will advertise on network on the OSPF full configuration. And OSPF authentication can configure OSPF MD5 authentication in two ways. One is on the interface level, we configure the two commands. This is for interface. And if you want to enable authentication for all for all interfaces in the entire area. We can conquer on the hotel OSPF, conquer area number authentication master address. This command is, instead of type this command, we type this command on the OSPF process. Then on the interface level, we conquer this command. I prefer multi this key number and MD5 password. It's the two ways of MD5 configuration. Okay, now let's configure. The configure SPF area 0 between 3, 5, 6, and 4. Then let's pause and open the. Okay, now let's configure. This is our topology. Okay, configure SPF area 0 between 3, 5, 6, and 4. This is our router number 3. This is 5, 6, and 4. This is area 0. We have area 0 between these devices. Let's check area 0. Okay, it said don't use interface level commands to establish an adjacency between 3 and 5. Between 3 and 5, we don't have to use interface level command for establishing adjacency. In other words, to add without network. We have to use network under network command under OSPF configuration. Okay, let's configure R3 first. R3. Enable config T. OSPF process ID 1. So between R3 and R5, let's bring this R5 here. If I do show IP interface brief, which is this address between 3 and 5. Okay, as I explained before, for SPF configuration, we can configure interface level and we can configure global level. We have to configure global level between 3 and 5. We can use interface level config. Okay. And this network is 35. This is this network. should be 0. Okay, now let's come for our file. Quantity OSPF 1. We have to do this network. Zero, zero, zero. Area. Area 0. Okay, we are in the full state. Okay, use. Okay, let's conquer other protests in for interface level. I want to show you how to conquer interface level. I conquered the 3, 5, 6, and left 6 and 4. Let's see. What this up to conquer between 5 and 6, and 6 and 4. Between 5 and 6, let's come from 5, what are 5? And 6. This is 5 and 6. I will conquer interval level between 5 and 6. Okay, just go interface. And IP OSPF process ID a 0. Okay, now let's go on 6. Show interface delete. Property interface. This is this interface. And IP OSPF process ID a 0. Okay, now we have OSPF addresses between 5 and 6, or conquered interface level between 5 and 6. Okay, now I have to configure between 4 and 6. This is for I will conquer on interface level between 4 and 6 either. Let's just go to interface. Interface. We have IP OSPF process ID area 0. And let's go on 4. Okay. Ensure interface brief. Interface. This interface. IP OSPF area 0. Okay, now we have OSPF adjunctions. Okay, this second part, we are configuring OSPF area between 3, 5, 6, and 4. We didn't use interface command between 3 and 5. But for other devices, we have used interface config. Okay, now use a network type that does not generate type to LSA between 5 and 6. Yeah, between 5 and 6. We have to use network type that shouldn't generate type to LSA. Okay, if we see our network, the network that starts with point, such as point to point, point to multi-point, and point to multiple on broadcast, this type of networks will not generate type to LSA. And we don't have regular election. Okay, but we can use this three type, but because point to multi-point will advertise hash root, point to multi-point will advertise slash 32 network, but here we have slash 24. I will use point to point instead. I can use point to multi-point, and point to multi-point broadcast in BMA, but for this scenario, point to point is the best because it will not advertise hash roots. I will use point to point. Point to point for between R5 and R6. Point to point will not generate LSA type 2. Okay. We don't have to specify a neighbor. It's auto neighbor discovery for point to point. Now 5. Let's go interface. An IP OSPF network. Point to point. I can specify point to multi-point, but point to multi-point will generate as source. This is point to point. Okay, now I have to specify this side either. Point to point. Interface. 5, 6. IP OSPF network. Point to point. Okay, this is this part of point to point between 5 and 6. Point will not generate type to LSA. Okay, now ensure that hellos are sent using unicast between 4 and 6 and use a hello interval of 30 seconds. Okay, between 4 and 6 you have to use network type that uses unicast instead of multicast. And we have to use hello of 10 seconds. Okay, if we check our network type, which network type uses unicast? In summary, in non-broadcast networks, for example, point-to-point, NBMA and NBMA, number multi-access, hellos are sent via unicast. And we have to specify neighbor command for neighborship, for the neighborship. Okay, we have to use network type number, that's network type. Between, that is non-broadcast network type between 4 and 6. Okay, non-broadcast. This is MBMA, multi-access. Okay, in MBMA, hello timer is 30, but we have to use specify 10. We have to allow hello timer. Okay, let's go on between 5 between 4 and 6, non-broadcast. Ground import, network interface, 4 and 6. This one, OSPF network, we have to use non-broadcast. Non-broadcast allows are sent via unicast. Okay, now 6 interface 4 6 OSPF network number just. Okay, because it is non-broadcast, we have to specify neighbor. Neighbor is this one. Just go into router OSPF 1 and we specify neighbor. Neighbor because this is 6, I will specify 4. These are neighbor. We have the same in R4. R4. This is this neighbor. Then I'm going to whether OSPF 1 and specify neighbor. This should be 4. Others, excuse me, 6. Okay, now we have adjacency on this interface. Okay, I have to use hello interval of 10 either. IP OSPF. Okay, on the interface, after the interface level. Interface between 4 and 6. IP OSPF. Hello interval. That is for 10. On the 6. Interface OSPF algorithm of 10. Okay, now we have to authenticate our current and future AR0 adjacencies with password of this I am AR0. Okay, because it's we have to our current and future AR0. We have to because it's a future for authentication is not for authentication or is for authentication. I can use this way on the interface. I can go this to command or on the for all areas because it says future. I have to use this this type of authentication on the with OSPF. I specify area number authentication material address and on the interface level I type this command. I put my material key number and password. So let's start with R3. Let's copy the OSPF one. Area 0 authentication message address. Then on the interface between 3 and 5, let's start the following. Between 3 and 5, interface or after this command IP OSPF which is address key 1 and the bar and this is I have this I am area 0. Okay, let's go on the 5 quantity for the OSPF 1 area 0 authentication message address. Then on the interface level between 3 and 5. Interface Ethernet. IP OSPF. Message address key 1. MD5. Continually type this key. For now, let's do now between 5 and 6. 5 and server interface. This card. And on the 6, first I have to go with the OSPF 1. AF0 authentication master digest. We're going to interface. It should be this one. Master digest. Okay, now between 4 and 6. Just for interface. Type this command. And let's go on 4. To the OSPF 1. IF0 authentication message digest. Go on the interface. This interface. And type this command. Done. Okay, this is this part and last section. The loop back network of 3, 5, 6, and 4 should be seen as type by LSA within area 0. Okay, for to force the loop back as type part, we have to distribute this loop back into OSPF. If we distribute this network into OSPF, then OSPF will see it as type part LSA. Okay, now let's go on. Start with the 3. Let's create route map. Let's start. Okay. To OSPF. Permit to match our loopback 0. Match interface loopback 0. To show down. So this is here, here, and here. Okay, route map and match our loopback 0. Now let's distribute it into OSPF. Simply go to water OSPF 1 and BBC, this is loop path, this is connected. Subnet, you have to specify subnet. Then I specify route map. Then I would mark name. Let's do December 7th. Oh, let's see. SPF one and copies. Okay, now let's verify. Okay, now this show IP OSPF database. Okay, in show IP OSPF database, we have hotel hotel link state, then police for area 0, and with this type by LSAs. 643, 45, and 6. So check other databases. We have type 5, and 5, 6, and 4. And we we don't have a DR, BDR, we don't have type 2 LSA for 4, 4 and 6 and so on. This is step. If I do show IP OSPF, in the start show IP OSPF, I can see my shared address. The backbone, area backbone, some matches, area has matches address authentication. You show IP OSPF, maybe. This is our OSPF neighbor. On no DR BDR election between 5. If I check here, show OSPF neighbor between 5 and 6. We don't have DR BDR. Type 2 LSAs. Type 2, no, we don't have DR BDR election. Between 6 and 5. Try to show OSPF neighbor, CDR, show OSPF neighbor, CDR BDR. We have database, and we have type 5 LSA because we have the distributed loopbacks into OSPF. Okay, this was our OSPF. So this was long, it takes a little long. I hope you have enjoyed this video and thank you for viewing.